There is a difference between what we want to be true and what the world actually runs on. Right now, in one of the most strategically critical regions on Earth, that difference is being exposed in real time. The Iran conflict and escalating tensions around the Strait of Hormuz are not just geopolitical headlines. They are a live demonstration of how fragile, complex, and brutally dependent our modern world still is on energy systems that many people claim we are rapidly moving beyond. We are not, and the consequences of pretending otherwise are now visible. Roughly 20% of global oil supply moves through a single narrow maritime choke point, the Strait of Hormuz. But this is not just about oil. Through that corridor flows liquefied natural gas, petrochemical feedstocks, fertilizer inputs, industrial gases like helium, refined fuels. These are not optional commodities. They are foundational. Without them, the systems that sustain modern civilization begin to fail, not gradually, quickly. Energy is structural, not optional. The dominant public narrative treats energy like a utility. Flip a switch, charge a battery. But energy is not a layer on top of the economy. It is the base layer. Everything else sits on it. Healthcare depends on sterilization, plastics, pharmaceuticals derived from hydrocarbons. Transportation depends on liquid fuels with high energy density. Construction depends on steel, cement, and petrochemical derivatives. Digital infrastructure depends on energy-intensive data centers and global supply chains. Even the so-called clean economy is built on energy-intensive extraction, processing, and manufacturing. There is no version of modern life that is not energy-dense. Introduce disruption. Insurance premiums for tankers spike. Shipping routes become uncertain. Military risk increases. Even without a full blockade, friction alone is enough. Prices react instantly. And here is the key point most people miss. Price signals propagate faster than physical shortages, meaning the economic shock begins before supply fully breaks. And that shock spreads globally, not just in fuel, in everything. Agriculture is just the beginning. Fewer understand that it determines whether food exists at scale. Fertilizer production relies heavily on natural gas. Remove or restrict that input, and global yields decline. This is not theoretical. During past energy shocks, fertilizer prices surged several 100%. Farmers reduced usage, crop output declined, food prices followed. Now extend that logic globally. The Iran crisis is not about oil. It is about calories. Let's go further. Steel production requires coking coal and high-temperature processes. Cement production is one of the most energy-intensive industrial activities on Earth. Shipping runs almost entirely on heavy fuel oil. Aviation has no scalable alternative to jet fuel. Mining itself, which is required for renewables, runs on diesel. So when people claim we can rapidly replace fossil fuels, the question is, with what? At what scale? Under what timeline? Using which materials? There is a persistent assumption that electrification solves everything. It does not. Electricity is a carrier, not a primary solution, and it currently represents only a portion of total global energy use. High-temperature industrial processes, long-haul transport, aviation, maritime shipping, and chemical production are not easily electrified. Even where electrification is technically possible, it is often economically or logistically constrained, and scaling it requires massive infrastructure build-out. Grids, storage, transmission, all of which require materials, land, capital, and time. Now consider the supply chain behind renewable technologies. Solar panels require silicon processing, silver, and industrial manufacturing. Wind turbines require steel, rare earth elements, and massive logistics. Electric vehicle batteries require lithium, cobalt, nickel, graphite. These materials do not appear magically. They are mined, processed, and refined through energy-intensive systems. And critically, much of this processing capacity is geographically concentrated. A significant portion sits in China. So we are not eliminating dependency, we are restructuring it. From hydrocarbons to minerals, from distributed production to concentrated control. That is not energy independence. That is a different form of vulnerability. History does not support the idea of rapid energy replacement. Energy systems accumulate, they do not disappear. Global coal consumption is still near record levels. Oil demand continues to rise. Natural gas usage is expanding. At the same time, renewables are growing. This is not substitution, it is addition. Because demand keeps increasing. Billions of people are moving toward higher energy consumption, not lower. They want refrigeration, transportation, healthcare, digital access, industrial capacity. These are not luxuries, they are development. So when policies assume declining energy use in a growing world, they are not aligned with reality. Now we need to address something directly. Climate projections are often presented as deterministic outcomes. They are not. They are scenario-based models built on assumptions. Assumptions about technology, policy, behavior, economic growth, and energy systems. These models are useful tools, but they are not predictions with certainty. Yet by the time they reach media and policy discussions, uncertainty is stripped away. What remains is a simplified narrative, and policy built on simplified narratives tends to fail in complex systems. Energy policy is increasingly driven by targets, net zero by a certain year, rapid phase-outs, aggressive adoption timelines. But physics does not respond to targets. Supply chains do not respond to slogans. Infrastructure does not build itself on timelines set by political cycles. When policy gets ahead of physical reality, the result is instability. What happens when energy systems are constrained prematurely? We have already seen glimpses. Energy shortages, price spikes, industrial slowdowns, increased reliance on imports, and in some cases, a return to higher emission fuels when preferred options are unavailable. This is not progress. It is regression driven by miscalculation. The Iran crisis strips away abstraction. It shows in real time how dependent the world still is on hydrocarbons, not because of ideology, but because of physics, scale, and infrastructure. It shows how quickly disruption spreads across systems, energy to industry, industry to food, food to stability. The real conversation is not fossil fuels versus renewables. That is a false binary. The real challenge is how to build a system that is reliable, scalable, affordable, resilient across all sectors. That likely includes hydrocarbons for decades. It includes nuclear. It includes renewables. It includes innovation we have not yet scaled. But it requires honesty about constraints. The world is not transitioning away from energy density. It is competing for it. The Iran conflict is not an anomaly. It is a signal, a warning about how fragile the system is and how dangerous it is to build policy on narratives that ignore complexity. Because reality does not adapt to belief. Systems either work or they fail. And when energy systems fail, everything else follows. If this video gave you a clearer way to think about energy, then you already see something most people don't. Because the world is changing fast, understanding what's really happening with climate and energy policies has never been more important. This channel is about cutting through the noise. No hype, no extremes. Just clear, grounded thinking about energy, climate, and the systems that shape our lives. If you value that kind of perspective, welcome aboard. Please take a moment to like and subscribe if this helped you see things differently. Please share and turn on notifications so you don't miss what's coming next. Because the next decade of energy decisions will shape everything. So the more we get people to understand the reality, the better for us all. See you in the next one, and stay well.